So fantastic. We are streaming this on live on YouTube. So if you'd like to turn off your channels, you're welcome to. I'd like to welcome everyone here to Let's Get Together. We're a nonprofit organization that is about creating opportunities for families, youth, children, communities to access resources that supports education and well-being. And we do it in many different ways. And this is one of the ways. We've got an amazing astronomer, Ryan from Astronomy in Action, who's going to be delivering a really cool presentation. But it takes a team to deliver something like this. So we'll put our contact information below, but want to introduce you to our student group, the STEM It Up Science Student Group, head by Alyssa, who will introduce what STEM It Up is. So Alyssa.
Hi, everyone. Thank you for coming to this event. My name is Alyssa. I'm one of the student ambassadors for the STEM It Up group. The STEM It Up project encourages STEM, science, technology, engineering, and mathematics learning and educates Canadian middle school and high school students and learners of all ages about it through fun and interactive STEM activities, videos, and events like this Astronomy in Action live stream. Astronomy in Action live stream programs explore the night sky as viewed from your location. We view constellations, explore the planets, and even fly around the galaxy and beyond. All the programs are inquiry-based, encourages participation, and seeks to have the participants drive the program through their curiosity and questions. This highly visual experience seeks to show the wonders of the universe as a professional astronomer guides our tour of the cosmos.
Fantastic. And what we'd like to do now, thank you, Alyssa. And Alyssa attends the University of Guelph Humber. I'm going to introduce Roba. So,
hello. My name is Roba. I am a student in the University of Guelph Humber, and I'm here to present to you Ryan. But before I do that, I would like to mention Guelph Humber's Chair of Science Rendezvous, which is going to happen on May 8th. And as Allison said, it's going to be from 10 to 3, and you can join in and enjoy all the different science challenges. But allow me to welcome Ryan Marciniak, who is an astronomer, a science communicator, and the founder of Astronomy in Action, which brings 2 portable planetariums that brings the universe to communities across Canada and Ontario. Audiences see stunning 4K visuals of the true night sky with a professionally presented 360-degree theater, allowing guests to experience the universe with wonder and awe. He also does live streams and live workshops across Canada using amazing visualization of the universe to educate and entertain. Welcome, Ryan.
Thank you very much. I am excited to talk to everybody tonight. So thank you, Allison. Thank you, Alyssa, and thank you, Roba, for the introduction. Let me actually say hello. There is always a real person behind the screen, but the logo is just kind of the front-facing thing. First off, I have to say Science Rendezvous on May 8th is an amazing event that I've been a part of for at least the last 10 years through different institutions. I can't recommend it enough. It's a great way for the public to connect with real scientists. And I will be working with University of Guelph Humber this year on May 8th to bring some really cool virtual programs to everybody out there to really engage with what's happening in the world of science. So stay tuned for that. I can't really reveal too much right yet, but it's going to be a lot of fun. But hey, we're here to talk about Mars. I want to thank everybody for tuning in on the Astronomy in Action YouTube channel, on the Zoom call, and of course on the Let's Get Together YouTube channel. This is our first time broadcasting through so many channels, but we're here to talk Mars? I see a couple of questions in our Zoom chat already, which is really wonderful. And I am going to answer those as we go through, but I want to start out with the big news, of course, what we're here to talk about, the Perseverance rover. This is the next Mars rover. It's big, it's a big chunk of metal, it's got a nuclear battery. It sounds pretty mad, pretty bad, pretty awesome, right? And it's flown to Mars since about July 30th of last year when it launched. And I want to go kind of through the entire mission, talk about why we would send this mission to Mars, how it gets there, what it's going to do, and just how amazing it is that a bunch of human beings could get together and do something this amazing. So I'm gonna start with, of course, the launch, which happened back on July 30th. As far as rocket launches go, it was pretty standard, but it's an exciting thing to watch. I remember watching this live last July and taking a look at it and seeing that, yeah, this big rocket carries in it not just this multi-hundred million and billion-dollar robot, but a lot of really amazing scientific technology, the names of over 10,000 individuals who wanted to get their names etched on the rover to send it up to Mars. I'm going to skip ahead a little bit because we don't want to sit here and look at the rocket for a minute and 30 before it actually launches, but we're going to see just the launch just so we get an idea of how these rockets work. These are often used to send up satellites. This one's got a bit more oomph because it is going to another planet. And here we go with the launch. You can probably hear a little bit of the audio. I don't want to deafen everybody with it, but there it goes. Typical standard launch. Human beings are getting a lot better at actually launching things as well, which is kind of exciting. Immediately, the rocket starts to turn as it goes up. It's trying to get into orbit around the Earth. And once it gets into orbit around the Earth, then it can accelerate further and make the trip to Mars. Mars is not too bad as far as spacecraft flights and space flights go because it's relatively close to the Earth. Now, I say relatively close, it's still several 100 million kilometers away. This trip, the landing happened yesterday. So when it launches in July of last year and takes 8 months to get to Mars, that's a long way. And that's eventually going to become important when we get humans to Mars. It's still an 8-month trip. So here goes the rocket into outer space. It is going to lose its small booster on the back. And at the very top is what's called a fairing that covers the payload, which in this case is the rover. Here it goes up in orbit. I always love seeing the cameras showing the spacecraft in orbit as it's going faster. You can see the speed, 12,000, I think that's miles per hour. So about 1.6 times that for kilometers. So around, I guess, 17, 18,000 kilometers per hour, going really, really fast. Oh, we lost the camera feed for a sec, but there you go. It is up in space. You see here, this is a simulation of the rocket without its small booster, the payload in the front. And this traveled nonstop to Mars from July 30th until yesterday. All right, we see a little chatter from some of the people there, but we're going to go and take a look at just how it gets there. The real key is this thing called a Hohmann transfer orbit. Now, this was launched right when the Earth was fairly close to Mars, right before what we call opposition. When we have Mars and the Earth lining up with the sun, we call that opposition. And it wasn't quite there. You don't really want to launch at opposition. You can see Earth here in the blue, Mars in the red. This is about where the launch happened. And so this launch happens, and then a few months later, we get to Mars opposition, where Earth and Mars line up perfectly. This will be a little bit later. So there we go, right about there. And in this time, the spacecraft has now left Earth, is slowly working its way towards Mars. Generally, the thing is that when spacecraft fly from planet to planet, objects that are closer to the sun tend to orbit faster, and objects that are farther from the sun orbit slower. So Earth moves faster in its orbit around the sun than Mars does. And so that's why you have to launch it early so that rocket has time to go and slowly make the transition between Earth orbit and Mars orbit. And then we keep going, we get a little bit further forward in time. Earth jumps ahead of Mars, as you can see, and then we get to where the actual arrival happens. And so you can see that, Earth travels about halfway through its orbit. That's 6 to 7 months. Mars in 6 to 7 months doesn't go that far. Mars takes about 2 Earth years to work its way all the way around the sun. And so sure enough, this rocket made it all the way to Mars very, very carefully, and just yesterday landed. Now, the thing is this landing is very, very difficult. Here's kind of what happens. I'm going to show you a video of what happens as well, but basically it goes through this procedure where it has a heat shield on it. It slows down as it enters the atmosphere, releases a parachute to slow down further, releases a rocket booster to slow down further, and then a small tether releases the actual robot. So let's see what that is supposed to look like. It takes about 7 minutes to happen, start to finish. But the challenge is that you can't sit there and control it like a drone, right? Where you say, oh, go up and the drone goes up, or go forward and the drone goes forward. Unfortunately, you can't do that because Mars is so far away. It actually takes about 3 minutes for a signal from Earth to reach Mars. So if you tried to control the robot like that, well, by the time that 3-minute signal, or that signal traveled the 3 minutes to Mars, the robot would already be lost. So this entire process is automatic. This entire landing is automatic. And you have to, the scientists, the engineers, the mathematicians who built this robot, who sent it to Mars, have to trust that they've done everything they can to make it work successfully. And so it does happen automatically. So you see it slowing down as it enters the atmosphere with its heat shield. Mars does have atmosphere, about 100 times thinner than Earth's, mostly carbon dioxide, but still enough to cause something to heat up and burn up. So it slows down with the heat shield. We saw the rover inside just a second ago. Once it slows down enough, a parachute is triggered, again, to slow it down in Mars's thin atmosphere. The heat shield will open up. We will talk about the landing site and everything pretty soon. So the heat shield opens up. There it goes. And the robot drops down with this little retro rocket on it. This is such a novel way to land a spaceship, to land a rover rather, is because now you're trusting this little frame with its own little rocket engine to take the rover, which is the size of a small car. Like it's not light, it's heavy. And to take this car all the way down to the surface without accidentally tipping or moving sideways. One error, even at this point, could ruin the rover completely. But it works. It worked with the Curiosity rover back in 2012. That was the last rover that landed on Mars, and it's working well with this one. And it worked perfectly yesterday. So tethers drop it down. It undergoes this nice landing. The tethers release, and the booster rocket actually launches itself away so that it can't damage the newly landed rover. And there we go. Operations can begin. So this happened yesterday afternoon. Like I said, after traveling from July 30th through space, about 600 million kilometers to get from Earth to Mars on that transfer orbit and bring it here to the planet Mars. So it did actually land, and I just have to show you just the reaction of everybody who was in the control room yesterday experiencing this. Can you imagine how nervous these people are? They've spent over a decade building this robot, preparing everything, the tiniest details, to land it somewhere 600 million kilometers away. And it all comes down to this 7 minutes of terror where they just can't watch it. They just have to hope, like a parent sending a child off into the wild, hoping that they can survive on their own. It's kind of the same thing. So there you go. And it actually did work. And so it's just the jubilation that they experience when they get the confirmation that it lands successfully and they are in operation around Mars. Some of these people have spent their entire careers working on this to this point. So it's a really, really nice moment. And then they send back the first images, which I'll show you pretty soon, the first images from the rover to ensure that it is working properly. Very exciting for all of those people. And it's important to remember that there are actually people working on this kind of thing, right? Lots and lots of people. So here's a couple of neat images. There's another orbiter around Mars called the Mars Reconnaissance Orbiter, or MRO, Mars Reconnaissance Orbiter. And it's actually, it took a couple of photos of the parachute with the rover as it's going down. So this is another spacecraft in orbit, just kind of sneaking a peek as the landing happens, which is really, really cool photo. Really cool photo. And then Perseverance, this is a really neat photo. This is from the booster rocket with the tethers attached, still several hundred meters above the surface of Mars as it's lowering itself down. This is a photo that you just don't get. So that's really, really incredible, a real photo of the rover. And I imagine when this one came back, all the engineers and scientists at NASA were really, really happy to see this operating properly. And then this morning, we got the first color image taken by the rover on the surface of Mars, which is pretty spectacular. You can see, you know, one of the things that often people tell me when they see these photos of actual Mars, they say, well, why is it not red? It doesn't look that red. Mars's soil is actually kind of brownish, right? But when you extend that over the size of an entire planet, it looks a little bit more reddish. And the other thing is that some of the first photos of Mars that ever came back in the 1980s and 90s were actually false colored to be more red, because people wouldn't believe that it actually came from Mars when they had this idea that it was a very red planet. So photos today, we don't need to false color as much. People believe that they're actually from Mars, and this really is. So where did this thing land? Oh yes, this is fun. Okay, so we're on the surface of Mars. Let's take a look. This is called the Jezero crater. By the way, I do see the question in the chat from Sebastian about waiting for samples to come back. I am going to talk about that a little bit later when we get into the sample return. So thanks for asking that question, Sebastian. And by the way, anybody who does want to ask anything about the mission as we go along, please feel free. I do love answering everyone's questions, and we can easily talk about anything to do with this amazing, amazing mission that just landed yesterday. So this is really neat. This is found on the NASA website. It is a visualization of the landing location. Now, this landing location is called, as you can see, Jezero Crater. It's really hard to choose a good landing site on Mars because you want to get as much scientific value out of the landing location as possible. Oh, okay. See, now we get a couple of questions in the chat already. So, you know, Sebastian, I actually don't know how big the Jezero crater is. I think it's I would guess about 100 kilometers. Oh, look at that. I'm twice right. It's 45 kilometers wide. So the entire Jezero crater, edge to edge, is 45 kilometers wide. From Shreeman and Lavina, is it possible to live on Mars? It would be possible to live on Mars, but just like going into space, human beings would have to bring our own air, our own water, our own food. Living on Mars, just as we live on Earth, is not possible. We need to bring water with us, or at least a way to purify water. We need to bring air, or some way to produce air, which can be done from water. And we need to wear spacesuits because the air on Mars is too thin for us to breathe. It's made of carbon dioxide, which we can't breathe. And it's very thin. Mars is also about minus 50 degrees on a normal day. So it's really, really, really tough to live there without a spacesuit and the proper equipment. So we're going to talk about that a little bit later when we do eventually get to why people are going to go to Mars. So Lee Canning asked, how long is the rover supposed to stay on Mars? That's a great question. The rover's supposed to be on Mars until it stops working, which is a very long time. There are rovers that have been on Mars since they landed. There's no plans to bring them back. It is a one-way trip. They go to Mars to operate and do their science. The Curiosity rover is a good example, has been operating since August of 2012, nonstop, still going, still operating. When it does eventually run out of power with its nuclear battery, it will stop operating and just stay there until humans go and get it maybe someday. So that's kind of an exciting thing. Some other rovers, Spirit and Opportunity, earlier missions that some of us slightly older folks will know about, they lasted for 12, 13 years before running out of juice and sent back amazing science value. So the rovers basically will stay there forever or until somebody goes and gets them. And I hope that someday human beings will go there in order to get these rovers back, to put them in a museum so that people back on Earth will eventually get to see them and all the amazing work that they did. Pretty cool. Let's see, Lauren asks, did NASA choose the crater location or did it just happen to be in the area that the rover landed in? Great question, Lauren. When it comes to finding landing sites, NASA is very, very careful about choosing them. Now, you remember the photo I showed about the MRO, Mars Reconnaissance Orbiter. This is a spacecraft that has been in orbit of Mars for many years now, and its job is to map the surface of Mars and look for the valuable sites to land on. There's a reason that the Curiosity rover, sorry, Curiosity, I'm used to saying Curiosity. There's a reason that the Perseverance rover is landing on Jezero Crater. There's a reason for it. It's because it's one of the most high scientific value targets. Now let's think about the last couple of rovers. Spirit and Opportunity launched in, I think, 2002, 2003. Their goal was to try and look for water on Mars, and they found water on Mars. The Curiosity rover in 2012, its goal was to look for signs of potential life, to find some of the necessities of life in the crust of Mars, and it did that. So there could have been life in Mars in the past. This is the first mission, the Perseverance rover, where one of the goals is actually what we call astrobiology. Perseverance is the first astrobiology-focused mission, which is actually going to collect and store samples of Mars rock and soil to see if there are fossils in it, to see if there are sediments containing minerals, elements that are only made by life. So the reason that we're in Jezero Crater is if you look at it, you can kind of see there's a little inlet kind of river here. And this is an ancient river, believe it or not. And as water used to flow in here, it actually flowed into this big open plain. And you can actually see a bunch of sediments here flowing into the big open plain. This is called a river delta. Now on Earth, we have river deltas. Here's a great example of one on Earth. This is in Papua New Guinea. So you can see, just as with the photo we just saw, didn't the crater used to be a lake, says Sebastian? Yes, absolutely. Does this water float in to the crater? Or in this case, this is the ocean, I believe, in Papua New Guinea. And look at the sediments, the darker kind of tan colored sediments come from the river and are kind of pushed out into the ocean. And the idea is that if there was ancient life on Mars, river deltas are a great place for a strong diversity of life to thrive. And so if the same is true of Mars, then this is a great place to land. It's showing all the different mineral types and relief here in Jezero Crater. So this is why it was chosen. Going back to Lauren's question, this is why we chose this, I say we, but this is why NASA chose this site. It was because of this river delta being right here, a very unique feature, very hard to find on Mars of all places, but a place where on Earth we find lots of life. So the idea is that by studying samples and rocks and minerals in this region, we might be able to find evidence of ancient life. Pretty amazing. And so we can go in closer and see where the rover actually landed. So it did actually land right here, which is a great landing spot, nice and open. You can see some hills here. There's craters. There's a lot of dangerous places for this to land. And so it's really important that it found a good landing site that was safe and secure. What's going to happen with the rover eventually is that it's going to, let me find the photo I wanted to show you. So there is a possible path for it. So kind of make note of where it is right now. And so here's a potential path for the rover. This is another thing that's mapped out by scientists at NASA, by engineers, by people who are using data from the Mars Reconnaissance Orbiter to try and figure out, well, once the rover gets here, once we decide on this location, how is it going to get up higher up and find really good places to take samples, really good places to do science, really good places to study. And this is one of those possible paths. So if we go back to the visual here, you can kind of see there's this ridge. Let me just show you here. So this ridge right here and this crater, the rover's right there. If we go back to the path, you can actually see there's that crater, there's that ridge. So the rover is just a little bit further to the bottom of this image. So this is a really good place, a really good pathway for the rover to go up this hill, to take samples, to take rock samples at different layers, and work its way all the way up the river delta into the river and up on the plains here. And the idea of going through different layers of elevation is that just like on Earth, when we dig deeper, it's like a time capsule looking into the past. Geologists on Earth dig deeper down into the Earth to find different layers of rock that are, like I said, like a time capsule. They have minerals that were formed at that time. They show it just like the rings of a tree can show years of better growth and more rainfall and lesser growth or fires, right? You can learn the same thing from looking at rock layers. And so, so the Perseverance rover, as it goes through all these different layers, is going to take samples of different rocks that's going to help us piece together the history of this region and potentially the rest of Mars. Okay, so we've got some more questions. I'm going to go back to the visual of Jezero because it's really, really cool. Like, I think this is just such a neat image here, just showing, and you look at the, I mean, you can see the dunes, the sand dunes there from the winds. Mars does have wind. You can see that all this is sedimentary rock that's flowed out of this ancient river from several billion years ago, which is really exciting. Okay, a couple other questions. So, has the entire surface of Mars been seen or recorded? At this point, yeah, the entire surface has been mapped. The reconnaissance orbiter does map higher resolution imagery of places there that are potential landing sites. And that's just so that the engineers and scientists at NASA can look back and study the region in detail to see, is this a good spot? Usually what they do is they'll take high quality images. You can see that this is a higher quality image than the surrounding region, right? So they'll take this high quality image to study the area, compare it to 2 or 3 other landing sites, and decide if this is the best place. And Jezero was by far the best place for this rover to land. Is the surface of Mars really bumpy or is it flat? It's actually both. Some places are very smooth and flat. The surface of Mars used to have an entire ocean over the northern hemisphere. And so why don't we just take a quick pop over to see what the red planet looks like here in Universe Sandbox. There we go. So I mean, from high up, it looks very smooth. You can sort of see down here, it's a little bit bumpier. Jezero is in this area right around here. I know that's not a very good showing right now. This is a very low resolution map, but you'll notice that the southern half of Mars is quite a bit more cratered, quite a bit bumpier. Where if you look a little bit further north, there's less craters, it's a little bit smoother. We've got, of course, the big volcanoes, ancient volcanoes. So Mars is pretty smooth up in the northern parts because that is where there used to be an ancient ocean with as much water as the Atlantic Ocean on Earth, which is kind of cool. So Jezero is basically kind of in between the two regions, which is another reason it was chosen, is that you do get some of those highland features close to the ancient ocean, close to the rocky area, and you get some of those lowland features close to the ocean. So it's kind of that nice in between. Let's see, Sebastian says, is NASA going to try Mercury or Venus one day? I mean, there have been missions to Mercury. Messenger is a good example of that. And Venus, there's a Japanese probe called Akatsuki, which means dawn. That was sent to Venus 5 or 6 years ago. So you can look up those missions if you want some more info. Landing on Venus or Mercury is a little bit more advanced. Hasn't really been done quite yet. I mean, Venus has had landers on it, but Venus is the hottest planet, so it's a lot more dangerous than going to Mars. I see my good friend Jackson hanging out in our YouTube channel as well. Thanks for those of you tuning in on the YouTube channel as well. Feel free to ask questions in the chat there. And for the Let's Get Together channel, if there are questions in there, I'm sure Allison can relay some of those to me because that's what we're here to do, right? Okay, another question from Lauren as we go back over here. Will the Perseverance rover cross paths with Curiosity? Chances are no. I mean, the rovers, see, the thing is about being so far away, right? The fact that the rover is about 300 million kilometers from Earth right now, if something breaks down, there's no tech support. It's not like, you know, you break down, if a car breaks down on Earth, you go to a mechanic and they can fix it. On Mars, the nearest support is 9 months, 300 million kilometers distant. It's really hard to get there to get it fixed. So once it breaks, it breaks. And so every movement of the rover is very, very careful. Typically, the rovers only move a couple of tens of meters per day. They're meticulously planned out, all those movements. If we go in a bit closer, you can see here. So like even where the rover is right now, you know, there's dunes, there's rocks. Scientists are going to be looking for interesting rock formations as the rover slowly works its way through. It has to be careful about sand dunes because the wheels can get stuck. They meticulously plan out every single movement for those maximum 50 meters. They plan out what rocks they're going to investigate a little bit closer. The goal is for scientists to squeeze as much scientific value out of this mission. And time is money. Every day that it's there and not doing something is time lost. So they're going to be looking for immediately a way to take some samples, interesting rocks to study a bit further, and to start making their path to get to the higher up locations to continue their main science goals. And I will talk about those main goals a little bit later. But essentially the rovers, they don't move very much. They're very, very far away. It wouldn't make much sense to put this rover right next to the Curiosity rover, because then it would be looking at the exact same rock formations, the exact same topology, the exact same minerals. The goal is to study the diversity of Mars. So it makes very good sense to send robots, to send rovers, to send landers to all different locations around the planet for different purposes. And just like the Perseverance rover here has different science goals than Curiosity, the best place for Curiosity is somewhere else than the best place for Perseverance. Thank you for those great questions. That's what makes it really nice. I'm going to continue on with some more of the mission, and then I'll answer a few more once we get a little bit later into the program. We're half done already. Time flies when you're having fun. It's like I always say. So I love the fact that Jezero is very much like a river, is an ancient river delta. Water is typically the place we look for life. Water is where we look for life. And this river delta on Earth and New Guinea really shows you what we're looking at on this other planet. It makes the landscape a little bit less alien as well. So we looked at the possible path. Let's take a look at some of the instruments on the rover. I'm not going to go too deep into the instrumentation, but we do want to just take a look and see some of the things that are different between it and the Curiosity rover. One of the neat things, of course, it's got this long extended arm with some spectrometers, which are actually going to be able to study and analyze rocks immediately on the surface. So instead of having to send a sample back to Earth, some of the analysis can be done right on the surface of Mars, which is really amazing. There's the cameras on the top of the rover where its eye would be up there. The mast cam is very similar to the Curiosity rover. In fact, a lot of the design of this rover is based on Curiosity. At the very back of it, at its tail end, it's got what's called an RTG, radioisotope thermoelectric generator, which is basically a nuclear battery. It's the best way to think about it. And then this really innovative piece of equipment called RIMFAX there at the far left. RIMFAX is going to let the rover actually look a little bit below the surface. It's going to peer a little bit below the surface to see if there's interesting minerals or something to take a sample of. So that's a brand new instrument as well. But the one I'm most excited for, and this is one of the mission objectives. I'll read out the mission objective for Perseverance, the fourth one. It's prepare for humans. Test technologies that would help sustain human presence on Mars someday. And that's MOXIE at the very bottom there. It produces oxygen from the carbon dioxide on Mars. Oh, thank you, Beverly, for joining in. Yeah, thanks for that nice comment in the chat. So MOXIE is actually testing out how to produce air. Remember with Lauren's question about, or sorry, Shreeman and Lavina's question about, is it possible to live on Mars? It isn't, but if we can produce oxygen, now we have a chance to live there. So MOXIE is going to test out a way to produce oxygen. And if that works, when humans eventually do go to Mars, we can use something similar to that to produce our own oxygen to be able to stay there a lot longer so that we don't have to bring it all with us from Earth. All right, so that's a really important instrument as well. And we'll talk a bit more about those. But I want to actually show you the rover. I found a really neat 3D rendering of it in my program called Space Engine. Shreeman and Lavina also ask, is it possible to plant trees on Mars? I like that question a lot. There are scientists who are studying how to plant anything on Mars. It is, yeah, the soil's not great. There is, on Earth, some botanists, scientists are using what's called a simulated Martian soil. They're basically trying to recreate the soil on Mars and then try and grow things in it. So trees, it's not possible. Generally, to grow big things, you need a lot of oxygen, and Mars doesn't have that yet. I think the first gardens on Mars will be small greenhouses with oxygen pumped in, where it's just going to be plants that people can eat. And so that's kind of a big deal. But here's the rover. Now, the land looks really flat here. This is still a rendering, so it's not perfect, but the rover is kind of a high quality rendering here. You can see the big arm on the front with the spectrometers that's going to be taking samples. There you go, the Mars 2020. This is a very nice rendering as well. We can see the camera up at the top here. We see the, sorry, controls here are a little wonky. Those big wheels, there's the nuclear battery on the back, but I wanted to show you something really cool as I try and control this. A big suite of instruments. A lot of them are for studying the environment on Mars, but I wanted to show you this thing right here. Okay, so if you happen to send your name to Mars on this rover, your name will be etched right here in this nameplate. This is this little thing on the top there is a pulsar map to Earth. At least I think it is. You got NASA and JPL, the Jet Propulsion Laboratory, and in these three little squares are etched the names of over 30 million. I think that's 30 million. I can't read the number. 10 million maybe? Yeah, 10 million people, which is kind of cool. So there you go. Now you might notice there's this little helicopter up here. We're going to talk about that too. Sebastian asks, is it always night on Mars? Sebastian, Mars's day is only a little bit longer than Earth's day, about 24 hours and I think 19 minutes. Let me just verify that because I want to make sure I get the right answer for you. So Mars solar day. Yeah, okay, 24 hours, 39 minutes. So that makes it really tough because it's a little bit different than Earth's day. But Mars does spin. It does have day and night. The rover doesn't generally operate at nighttime, even though it does have a nuclear battery. It tends to go into kind of a dormant state because it gets so cold at night on Mars, can drop down to over minus 100 degrees. So it needs to preserve all of its technology so that when it wakes up in the daytime, it can operate again. It can take pictures and figure out where it's going to go. Okay, so let's roll on up. Ooh. Out of this poor rendering of Jezero crater, but I wanted to show you at least where Jezero is. Right there on the edge of this large highland plain on the surface of planet Mars. So it actually is there. So no, it's not always night on Mars, but if we work our way around, you can see the nighttime side over here. All right, so there is daytime and nighttime on Mars. Okay. So a couple things we're going to take a look at. We have that helicopter that I was showing you. It's called Ingenuity. Now, Ingenuity is a proof of concept. It's kind of like that oxygen generator, MOXIE. It's there as a test. Ingenuity is a helicopter on the surface of Mars. It is the first helicopter to ever operate on another planet. The first ever helicopter. And it's kind of hard to have a helicopter on Mars for a couple of reasons. Mars is about 2/3 the size of Earth. So it has less gravity, which is a good thing. But because the air is so thin, you need to have something, a helicopter, I guess, that's very, very light, has very fast spinning blades, and can operate pretty autonomously. So again, because you can't control this like a drone, because Mars, a light signal takes 3 minutes to get from Earth to Mars, you need to program in all the codes to all the operation commands, send them away, and hope for the best, just like with the landing. So this robot, this little helicopter, is going to just test out a flight. It's going to do some very simple commands. The rover, the Perseverance rover, is going to take pictures of it to make sure it's doing everything it's supposed to be doing. But it's going to go up into the air, test out some flight, see if it can remain stable, take some pictures of the ground, and see if it can actually work. The goal for this kind of technology on another planet would be that if we want to send a rover or eventually people to Mars, it would be great to have a little helicopter that could fly up high up, take pictures of the surrounding area, and figure out where are some good things to look at, where are some good rocks to study, where are some good places to establish a base, where are some good places to look for scientific value or water or anything. And so that will eventually save a rover valuable time to go and say, oh, well, hey, the helicopter found a really great looking rock over here about 100 meters that way. Why don't we head over there and go and study that rock? And so I think it's going to be a while before Ingenuity really gets to do its test. But again, it's not doing much operation. It's just a test. It's there to see if it can work, if it's possible. And then future missions will actually have helicopters like this to fly around. And this could eventually be really powerful on other planets, even like Venus with its thick atmosphere, or places like Titan, moon of Saturn, which also has a thick atmosphere as well. Another question. Oh, more questions in the chat. Shriman and Lavina ask, do all planets have day and night? Yes, they do. All the planets of our solar system have a daytime and nighttime. They just last different amounts of time. What we call that is the rotation rate. So Earth rotates in 24 hours. Mars rotates in 24 hours and 39 minutes. Bigger planets like Jupiter spin faster. Jupiter spins in just 9 hours. So one day on Jupiter would be 9 hours. Whereas a day on Venus is actually longer than a year. Venus spins so slowly that it actually goes around the sun before it gets to spin completely. So it depends on the planet. But they all do have kind of their own day and night cycle that makes them unique, right? It makes them interesting. Not all planets have the same day and night cycle as Earth, but Mars is pretty close, which will make it kind of nice when people actually do get to go there. All right. Are they going to send a rover or whatever to Pluto? That's a good question. Probably not. Pluto's really far away. And basically the way to think about missions in space is that the farther away something goes, the more expensive it is. Rovers are more expensive than landers. Landers are more expensive than orbiters. Orbiters are things that stay in space. Landers are things that land on the surface but don't do anything, or don't, I guess, move. And then rovers are things that land on the surface and roll around. It is a lot more expensive, a lot more difficult to land something on the surface than it is to put something in orbit. So if we want to talk about Pluto, the first ever mission to Pluto took 9 years to get there. It arrived in 2015 and it got great photos. But if we didn't know what Pluto looked like or where some good landing sites were, what's the point in sending a rover if it's going to fail, right? Because if you're spending lots of money on it, you want to make sure it's going to be successful. Yeah, 9 years. Pluto is about 3 billion kilometers away from Earth. So a lot farther away than Mars is. And this is another reason that we go to Mars, right? Is that when we look at, our solar system, when we look at Mars in this program, right? We see our solar system here. Earth and Mars are close together. Now I say close, it's still 300 million kilometers on a good day, but it's a lot more expensive to go farther to Jupiter. It takes 4 years to get to Jupiter. Saturn takes 7. Uranus and Neptune take that 8 or 9 years to get there. And even Pluto took 9 years. So the farther away you go, the more expensive it is. And it's much better to do some science on something that we have some established knowledge about. And Mars is a great example because it's close to us. We've mapped it very well. It has orbiters, it has landers. We have identified really good sites for scientific value, and eventually human beings want to go there. So it kind of makes sense to go and study Mars in depth with rovers because we hopefully will get to land there someday. All right, great question. Lauren asks, are there seasons on Mars? Mars does have seasons. Seasons tend to happen because of the tilt of a planet. So in its orbit, you know, the Earth is tilted. Oops, sorry, I'm all over the place here. Where are we going here? Oh, that's better. Okay, so the Earth is tilted 23.5 degrees. So when the Earth is on one side of the sun, the northern hemisphere is pointed toward the sun, and we get summer. 6 months later, the northern hemisphere is tilted away from the sun, and we get winter. That's basically why we have seasons. It's because of the tilt. Mars actually has a very similar tilt to Earth, so it has similar seasons: spring, summer, autumn, winter. We actually have found flowing water on the surface of Mars during the summertime when the temperatures can actually get above zero or very close to zero. It's kind of cool. So Mars does have seasons. They're not as nice as Earth's seasons, but they are seasons nonetheless. So, okay, so let's take a look. Now, a very early question from our friend Sebastian here was about sample return. So one of the things that this rover is doing that's a little bit different than any rover has ever done before is it's going to take samples of interesting rocks and minerals of soil, and it's going to leave them on the surface of Mars. It's just going to take a sample and leave it there. The idea is that someday, who knows how long, but someday another mission can go there, take those samples, and come back to Earth. And so this is how it does it. It's got a little sample collector drill. It's got the little extendomatic arm there. That's not its actual name. I just came up with that. But there it goes. It's going to drill down a couple of inches down into the surface to take a core sample. It's going to store that sample and many others it's going to seal them up in these sample chambers, and it's eventually going to leave them somewhere on the surface. They may stay with the actual rover, but they may be left behind it as it rolls around. And the idea is that if we could return some of those samples back to Earth, it would be incredibly valuable. Imagine being able to use an entire laboratory on Earth to study one of these samples. Sending the entire rover to Mars and trying to get samples from on the surface and trying to analyze samples on the surface, you have to send everything with you. It has to be small, it has to be light, right? Any amount of weight costs money to send. So you have to be so careful and be very cautious about what you choose to send on this kind of mission. And so being able to bring samples back to Earth would be incredibly valuable. Even a gram, 1 milligram of Martian soil or minerals today would be so valuable. They'd be worth millions of dollars here on Earth. And it's just like the moon landings. The moon samples, the lunar missions back in the 1960s and 70s, the Apollo, they brought back dozens of samples of moon rocks that were studied on Earth. And now we know so much more about the moon than we ever would have had we not gone there. So really, really valuable stuff. So let's go back to the rover. I know we're at Mars. We want to go to Perseverance. Persephone, no, Perseverance rover. All right, so let's go back down. And you can see where Jezero is here. All right, so we went in a little bit close. I do like the 3D model of the rover. It looks really cool. This is really good. You can see the helicopter hovering above it too. There's Ingenuity as we go in closer to that. Pretty cool. I hope it works. It's probably not going to get stuck there, but you know, it's computers for you. But there we go. So that is the mission. Now let's talk a little bit about the science objectives while we sit here and take a closer look at this rover. So there are 4 main science objectives. The first is geology. This rover, Perseverance, is going to study the rocks and the landscape at its landing site to reveal the region's history. So that's where we talked about before, digging down deeper beneath the surface to look at the history of this region. How much water did it have? What kind of sediment minerals are there? Were there elements that could support life? Are there fossils of actual life? Kind of cool. And that goes into our second goal, astrobiology, to determine whether an area of interest was suitable for life and to look for signs of that ancient life. If you've never heard of astrobiology, it is a fairly new field in space science, where you can be a biologist and study how life might form on other planets. Isn't that cool? So for any of you young people listening today who think about growing up and being an astronomer, or maybe you like life a lot more and want to study biology, you could study biology on another planet. You could study geology on another planet, and rocks and soil and minerals. There is so much more. You can study chemistry on another planet. The sciences are wide open for you if you're really interested in space and want to do something a little bit different. You don't have to be a pure astronomer like me, although it'd be cool if you were, because it's awesome. I'm biased though. Since Jupiter is a farther planet, would samples cost more? Yeah, if you tried to take samples of Jupiter, it would cost more money to get a spaceship out there and to bring something back, right? Basically, the three big factors for sending spacecraft and for looking at cost are distance, time, and weight, right? So how far are you traveling? How long are you traveling there for? And how long do you want the mission to operate? And how heavy is it? Those are the three big factors when it comes to putting money into missions, okay? How can you get samples from Jupiter? You could get samples of the atmosphere, or potentially samples from moons. Okay, so that's 2 science goals: geology, astrobiology. The third is sample caching. Find and collect promising samples of Mars rock and soil that could be brought back to Earth in the future. So that was that sample return that we looked at before. We might as well watch it again because it's kind of cool. And these are all videos produced by the Jet Propulsion Laboratory, who built the Perseverance rover. They do really, really nice media to make it really easy to communicate this stuff, right? Like I mean, I'm not doing the work. These videos are doing the work. I just get to comment on them and admire how cool they are, right? So, and then the last science goal, so we talk geology, astrobiology, taking samples. The last goal for this mission is to prepare for humans. Isn't that exciting? Isn't that exciting? To prepare for humans, to test technologies that would someday help sustain human presence on Mars. That's where that oxygen generator is. That's why we're sending the Ingenuity helicopter, right? Shreeman and Lavina have a space-themed joke. I'm all ears for space-themed jokes, as long as they're tasteful. So to prepare for humans, and in a way, these samples are a way to prepare for humans. And this is kind of, to wrap all this up, as we only have a few minutes left, the idea of sending these robots to Mars to prepare for humans is to study the regions of Mars, to figure out what works, where we want to go, what we need to know to live there. And basically the robots, these rovers, are doing everything that humans can't do. Eventually, we will reach a point with our understanding of the planet Mars where we can't learn anymore from rovers. We can't learn anymore from robots, at least not alone. And that's when we're going to start to send humans. A human being can do science much more efficiently than a robot can. So imagine sending a human. But this is where the challenge comes in. And this is where I want to go back to Sebastian's question very early on. I'm just going to putter back to it because it was very, very early. Why do we have to wait 13 years for the rocket to take the rocks back to Earth? Why not just bring them over now? And the reason is that when we send robots, we don't need to bring them back. We can leave samples there and they're not going to go anywhere. And then a future mission with future money can go and bring those samples back to Earth. But that's the difference between a robot and a human. If you want to send a person to another planet, now not only do they have to bring all the things that humans need, like food and water and air, that robots don't need, you also have to find a way to bring them back. So now it's twice the mission. Now it's 9 months to get there and 9 months to come home. And that is very challenging, very dangerous. This is why we have the International Space Station. This is why it exists. It is there so humans can learn to live in space for longer periods of time. Because even back in the 1960s and 70s, NASA scientists, engineers realized that if we want to go farther into space, we need to learn to live there safely. especially if we want to go and bring people back alive, which is the absolute goal. Why send people if we can't bring them back? So that's the big challenge, and that's what we're working on. So these robots will go to Mars to study, to test technologies, to find a way for us to eventually bring people and colonize the planet. And I know what your next question is going to be, is that when are we going to send people to Mars? When are we going to colonize the red planet? It's at least 10 years out, if not 20, if not 30. There's still a lot to do, but it's on its way. The red planet is within reach.
Wow.
Pretty awesome. And I think that's a good place to stop. Thanks, everybody.
Roba and Alyssa, that's phenomenal. Thank you so much, Ryan. To end it, the conversation, thinking in all of this, that Mars is within our reach now, and that we could have people, colonizing it, is quite quite a big thing to think about, but it's cool. So wonderful. Well, Ryan, thank you so much. Roba and Alyssa, would you mind signing on? And we're going to wrap up our conversation and our presentation. Alyssa has something to mention about a contest we have.
Yep. Hello.
Hi, everyone. Thank you for attending this webinar, and thank you, Ryan, for hosting this very interesting webinar. I would just like to mention that we have a space drawing contest. So could you please email a picture of your space drawing to letsgettogetherto@gmail.com. I'll put the email in the chat, and you will be entered to win a chance for a $25 gift card to either Amazon or Starbucks. You will get to choose either one, and the contest deadline is Wednesday, February 24th at 8 p.m.
So what they can do is draw any picture, any space picture, or does it have to be something related to Perseverance?
It's up to them.
Okay, fantastic. So we should hopefully get lots of cool space photos. So send your email, and you can have it to info@letsgettogether.ca or letsgettogetherto@gmail.com. Info is better. And then by Wednesday, the 8th at 8 o'clock, we will have a prize, a winner, and we'll announce the winner at that time there too. And if you also want to share it on, and I'm going to put it right here, you can also take a picture of your drawing and post it on your social media and tag us. And I think I've put it here in our chat box. Get Together TO, Astro in Action, because I know Ryan would love to see it, and STEM it up. And tag us, and it would, we'd consider it, we'd add it into the contest as well too. So Ryan, thank you so much for taking us on this incredible space journey.
Thank you,
Always
Ryan.
a pleasure. Always a pleasure. So much fun talking to all of you lovely people. I hope to be back for many more. It was a big event yesterday. Lots of people got to tune in, and we have a lot of years of great science to look forward to from Perseverance, Ingenuity, and the whole NASA JPL team.
And lots of career explorations too, which I found really exciting. And so, oh, the joke. So how do you know if a planet is married?
I don't know. How do you know?
Hint, Saturn.
I like the hint.
It has a
Ring.
on it. Love it. Awesome. Share that
Wonderful.
with your team. So everyone, thank you so much. And check out our website, letsgettogether.ca, for other incredible workshops that we have coming up. Thanks, and have a wonderful night.
Thank you, everyone. Have a great night. Goodbye.
Bye.
Bye-bye.
Bye.
Everyone, thank you for attending.